Started recording. All right. All right. Let's get started. Good evening, everyone. So today we are going to talk about machine learning. All right, and we'll talk about the different kind of machine learning, different algorithms. We'll try to understand the different elements in data, right? The kind of challenges that we face when uh, we understand, we make more meaning out of the data that we have gathered, right? So this is what we're going to cover, and it's beginning of this week. So in this entire week, we are going to cover machine learning, different algorithms. We'll see how some of the challenges which are pretty much practical and business oriented, right? How those are being addressed. All right. So let me move on. Uh, so while this is the broad agenda, we'll talk about data. We'll talk about, we'll give a definition to what is machine learning. Two different aspects that we are going to go and do a deep dive. One is supervised learning, unsupervised learning, and reinforcement learning. We'll not be able to go deeper into reinforcement learning. This course is going to cover supervised learning and unsupervised learning primarily. But I would happily invite you to experiment with reinforcement learning. I'll definitely give you some examples so that you find it relatable. Uh, but I'll suggest you to go through the content. I'll provide you the content as well, uh, and try to solve some problems, right? And if you bring it onto the table, right, we'll be happy to support it, right? And of course, throughout this conversation that we are going to do, right, we are going to pick up examples which are uh, they can start from basic, but you will find them relevant. All right. So let's talk about what is data. Now, in the first conversation that we did, right, we spoke about um, what actually has contributed to the AI wave, right? And we spoke about the availability of data was one of the reasons, right? Now, if you look at it, this is how the data is getting gathered in the last 15-20 years, right? Where the data is almost every year, the amount of data that we are compiling, that we are storing, right? It is huge, and it is exponentially high as compared to the previous years. So we have got IoT, Internet of Things, right? All the sensors, whether it is in the traffic or maybe environmental and all, right? So we are gathering a lot of data out of it. We have cloud platforms, which are also called as hyperscalers, right? And specifically, cloud platforms are important because a lot of telemetry data is captured, right? Now, telemetry data is all about the data that gets generated when you are using a particular product. So while we are using Teams to conduct the session, there is a telemetry data that is getting created, right? And it is available with the customer. I mean, the one who is actually using the product, right? In this case, TechBaton, right? And also, a part of it is getting relayed to Microsoft so that they can provide better services, right? Then we have got web scraping. Web scraping is very important. I'm not sure whether you have heard about it in the past, but considering LLMs, web scraping becomes very important. Web scraping is a process through which you actually crawl through all the web pages and and extract the content. Right. A lot of websites which are particularly in e-commerce world, they have been doing it in the past. They will log into their competitive portals, try to figure it out. Okay, what are the different products and what is their cost? And I'm not sure when you travel, which platform do you use to do the hotel bookings and all, right? Agoda is one of the platform. I think it's either European or US based. and they claim that in case the particular hotel is available at a lower cost, they will do a price match. Why are they confident? Because they are getting all those details, because they are doing this web scraping. Social media, of course, Facebook, Insta, right, LinkedIn, very prominent one. They are generating a lot of data. Then, if you are using any kind of OLTP system, consumer transactions, banking and all, right, that it will come into the picture, right? Then you are using a lot of apps day in, day out. So it is also generating a lot of data. Right? Geolocation data, which is actually the GPS location and all, right, that comes into the picture. Then we have got scientific research and syndicated database. I mean, it's more of a proprietary database that we have. Satellite images and biometric. I mean, if you look at all these combinations, some of these combinations actually have appeared, they have surfaced in the last 10 years, right? So we have got huge amount of data that is getting generated, right? And as I said, that actually in a way, it has also contributed to AI wave. But in the last 10 years, there is a lot of work that has happened to handle such kind of data packets, right? Now, I'm not sure whether you know structured data or unstructured data, right? So let's start this conversation to identify what is structured data with this quiz. So I'll start with the first question, right? Which of the this following is an example of structured data? So we have got five different options: a scanned handwritten prescription, a relational database table of patient IDs and claim amounts, an audio recording of a customer call, a free text complaint email. I'm not sure. What is your response to the question one? Kamlesh, you want to go
Option,
ahead? Or Mayank? Yeah, please go ahead.
yeah, option B.
Option B. Okay. Aditya also has called out this is option B. Anyone who actually differs? Okay. Let's move on. The second question is, which format is typically unstructured? Is it CSV file, JSON, MRI image file, SQL table? Or you are not sure? MRI. MRI. Okay. Yeah, Akshay, that's the right one. So MRI is an image file and it is unstructured. Right. So I think we know how things are. Okay. In a health insurance company, which of these is the best example of semi-structured data? Policy details stored in Excel sheet. Is it unstructured or semi-structured? Doctor's notes in PDF files. XML claim submission with nested tags. Call center audio recordings. B. Doctor's notes. B. Sorry, Kamlesh, you said B. Doctor's notes. Yeah. Uh, okay. And Shivani, you also said B.
No, sir. I'm thinking.
Okay.
I don't
Okay.
think so. It's B,
C.
but
So you said C
I did
with
not,
no.
sir. I
Okay.
think
Okay.
someone
Okay.
else.
Yes. Who said C? Akshay, me. All right. Okay. Anyone who will differ from Akshay? Okay.
I mean,
I
So
these
don't.
are all
let's see.
unstructured kind of data sets, but which one would be semi-structured? I think A. I'm not sure actually. I feel it's A. It could be A.
Okay. Okay. Uh, I heard a response from Rajesh as well. Rajesh, do you have a
Yeah, I'll
response
go
on
with
this?
I'll go with C.
We'll see. C. All right. Okay. Yeah. So C is the right answer. Uh, if you look at policy details stored in Excel sheet is actually a typical row and columns, right? It is a structured data. PDF files are
Okay.
actually all over. I mean, it's a textual file, right? So it is actually unstructured completely, right? XML claim is something which is in between because you have got tags, right? You know that okay, there is a definition available. You can identify each tag what it is communicating, but of course it is not available in the row and column structure. Right? Call center audio recordings are completely unstructured data. Okay, let's also answer this true and false. Structured data is always stored in relational databases. Is it true? Anyone? I see that Sanya is nodding her head.
True.
But is it yes? True. Who said true?
Action.
Akshay. Structured
Yeah,
data
I
is
guess
always
also
stored
true.
in. Okay. So this is a trick question. Sanya, you want to attempt it?
So not necessarily it should be in a relational database. It can be in simple rows and columns like Excel sheet.
Yes. Yes. So we just spoke about that the data which is in Excel sheet is also structured one, right? Okay, so structured data can be stored in relational databases. It can be stored in different formats. It just has to be in the rows and columns format. Then call transcripts from a call center are considered structured data. Is it true or false?
False.
False. Yeah, because we just
Hmm.
discussed that as well, right? Uh, okay. Uh, why we are talking about this, right? So let me give you an example, right? And it is a real one. So uh, we are working for a commercial insurer, right? They're developing products, right, which is going into the market, right? And one such customer, they have got they process the claims very efficiently with structured data. Right? Dashboard shows claim IDs, amounts, dates, and policy holder IDs. I mean, typically how the corporates would work, they have a report and you can see all the details with respect to how the claims are getting generated, right? And the top leadership is trusting the KPIs because this reports is self-explanatory, right? In case if there is an issue, the report will talk about it. What actually is happening, and this is a real example. So what happened? Uh, there was a warehouse that caught fire, right? Now you understand it is coming from a commercial insurance space. So if the warehouse has caught fire and the damages, the folks who are owning the data warehouse, they will reach out to the insurer, right, and put the claims, right? Very simple process. Now, what actually has happened? There is a fraud that has happened, right, which was not a fraud by design, right? It was not intentional. What actually happened when you are so data warehouse is a warehouse. Sorry, it's not a data warehouse. I'm sorry for that. Warehouse is where you keep the items. So maybe if I talk about Amazon warehouse, right? If I am a supplier for books, they will give me a location where I can put my books. Right? If somebody is into apparels, they will give a space. Right? Now consider this kind of warehouse which caught fire, right? And everything got burnt. Now, when the inspector came to do the inspection, right, they realized that okay, this is actually multiple parties have got impacted, right? And in the claim form, which was in the PDF form, the inspector called out that all these are actually a part of a single claim, right? It was a handwritten note in the PDF that got missed out, right? How people applied the claims, they actually went ahead and put the claims individually. So imagine five different companies and they're putting their claims individually, and there are a lot of overlapping expenses. Say, for example, the walls, right? Maybe they were fabricated using some woods and all, right? So in a way, uh, the money which was supposed to be claimed, maybe it was for 1 million, right? However, there was a delta that got added because of the overlaps, right? And when it was actually manually audited, that's where they realized that okay, there is a problem that has happened. They have actually given more claim than what they should have. Right? So somebody actually manually went through all the logs because this is how they do audit. They will pick up some sample, right, and will go through this manual stuff. Right. So this is a missing insight. So in case if you are not measuring unstructured data, this can be a fallback. Similarly, if you talk about customer services, right? You get a lot of calls. All those are getting saved. However, in the CRM system, it is all transactional, right? So in case if the calls, the kind of grievances the customers are sharing, right? If that is not getting stored, this particular data is getting discarded, right? It is of no use. So again, this is an example of missed insight, right? Then maybe the compliance team, they have got a lot of evidence which is available in the form of logs and all, right? And that is also not considered because maybe the team has no solution around unstructured and semi-structured data, right? So when you deal with structured data, and specifically when you're working as a data scientist, both the data are very important for you, very critical. Transaction data, understanding it and doing some processing, it has become now very rudimentary. The real challenge comes when you're dealing with unstructured data. So if I take you to the next slide, uh, structured data explains what actually has happened, right? In this particular case, it will talk about uh, what all claims have been processed, right? What were the submissions done, right, and so on. Whereas unstructured data, in most of the cases, it helps you to identify why it has happened, right? So here, fire inspector's notes will help you explain why this is happening, right? Similarly, customer frustration, which is actually getting communicated over the calls, it will help you to understand why a customer churn has happened, right? Customer churn means when customer moves out of the system, no more remains a customer, right? And if you have to measure why a customer churn has happened, you have to measure all the connecting points between your organization and the customer. So the call transcript is also one of them, right? So that's why it becomes very important that you measure, you analyze structured and unstructured data both. Any questions? Are we good here up till now? Okay. So if this is done, let's move on, right? And this is an example that, okay, the different data types that we have. We have got structured, unstructured, semi-structured. We already spoke about that. It is XML, JSON, right? And then we have quasi-structured as well. So the log files typically that you see, those are they fall into the category of quasi-structured. And we in data science, most likely you will be dealing with all these data. And not many times structured, unstructured, and quasi-structured. I mean the logs files. Okay. Now let's open machine learning. Right. Now, see, now if you look at this particular definition out here, and before we do that, right, let's talk about what is your understanding of machine learning. Anyone? The definition is of course written on the slide, but what is your understanding?
Uh, from my angle, I think so. Machine learning is when a piece of code or a program understands the pattern in a like when performing things. For example, we like build up a machine learning program of and like which takes an image and tells whether it's a dog or not. Like basic example. So we at first we give the program a lot of data about the dogs, like many images about the dog, and then when we have to test the program or the model, we give another image and ask whether it's a dog or another animal. So it can tell that it's a dog.
Yeah, very well said. Anyone else? Shivani, you want to give a try? What is your understanding on machine learning?
Um, Not very technical, but I believe, as the word suggests itself, the machines which are capable of actually correcting their uh, ways of performing based on the
Yeah.
input you give. That's all
Mhm.
I can say. Yeah.
Yeah, I think that that's good enough. Yeah. So, say machine learning is simply a program that can learn over a period of time and improve based on data. I mean, this is a very simple definition. Right? You don't have to go anywhere else. This is the standard definition, and of course, it is the same thing is communicated on Wikipedia slightly in a complicated manner. Right? But if you look at these examples, right, these are all implementation of machine learning, a recommendation engine, intent recognition, object detection, intent recommendation, where the different platforms are giving you different recommendations, right? So in case I was, since I have, I mean, if somebody is buying this book, right? This is my book only, so I have picked up this example purposely. So, in case if somebody is picking up this book, right? There are possibilities that they can actually also buy other books which are of the similar, right? Intent recognition here, in case if you are booking at a hotel, right, the Google, it will immediately let you know that okay, what are the hotels available, and it's actually picking up your location as well, right? So in a way it is able to identify, okay, probably you are looking for a hotel, and since you have not specified in which location, probably you are in your surroundings, you are looking for a hotel, right? And object detection is where you are identifying what objects are there, right? It can be objects, it can be things, it can be living beings and all. So these are the examples, right? And when we talk about machine learning, it can be divided into three different categories: supervised learning, unsupervised learning, and reinforcement learning. When we talk about supervised learning, in a way, as the name also suggests, somebody is supervising. So typically what we have in supervised learning, we have a data set which has got the actual outputs. And we very clearly know that, okay, what we are going to predict. In the beginning itself, the problem statement is well defined. Yeah, so this is supervised learning. Unsupervised learning is a situation where you have data, but you really do not know what you want to predict. And a lot many times we get into this kind of situations as well. So this is unsupervised learning, right? And then we get on to reinforcement learning. Now this is again a very interesting guy. Reinforcement learning is all about when you're writing a piece of code, it will learn based on the basis of penalty and awards. So, say for example, autonomous cars. So they will take probably they will move ahead by a meter, right? In case if there was it things were good, the algorithm will be awarded a plus point. In case if there was an obstacle that the algorithm was not able to identify, there will be it will get penalized. So this is how the structure works in reinforcement learning. Uh, so maybe you would have seen when you do use chat gpt, right, it sometimes it asks for the feedbacks, where if you like the feedback you can give a thumbs up, you can give a rating, right? And it also asks you sometimes multiple options, that okay, I have option A and option B, let me know your preference, right? So what happens, this data goes back to the chat gp or open AI, right? And they apply reinforcement learning on top of it, right? Otherwise, their models, once they have trained, it remains frozen for some time. Right? This is the way they actually can capture the real-time preferences from the customer. Right? So this is reinforcement learning. Any question on this? Okay, so let's move on. Let's talk about supervised learnings. So when we are talking about supervised learning, we have got a lot of columns. Um, we have got a label data. Label data is nothing but the output, right? And there are a lot of algorithms which are pretty much popular: linear regression, logistic regression, decision trees, SVMs. We'll talk about them. We'll also talk about in which particular scenario they can be useful. And lot many times what I have been seen in the corporate environment, in the practical environment, decision trees and SVMs, they are very dominantly used. Linear regression is kind of a very weak algorithm, but at the same time, uh, uh, it is still in use because it is easy to implement and easy to explain. Okay, let's move on. So if you look at it, see, this is the traditional way of doing programming. So uh, if you code something, right, you actually typically put a lot of rules. If this is going to happen, what will be the next step and so on, right? When you have written down all the rules, you pass on the data, right, and you get answers. Say for example, simple 3 plus 4, right? Uh, uh, that's the data that the user has given. Rule is okay. There is a addition that is happening, and the answer is 7. Right. So this is how the programming has been done. But when it comes to machine learning, there is a paradigm shift, and this is uh, you have data, input data, you have answers, and machine learning defines the rules. So this is actually very simple, but it's very important for us to understand. So what we are going to give 3 plus 4, right, and the answer. So we are giving three things. The different, I mean, the different two different variables and the answer, and the rule is that okay, addition. That's the rule it is generating. I hope this is clear. Okay. Now let's pick up this example. Here, what we have got.
Uh, uh,
Sorry.
no, quick
Yeah,
question.
please. Yeah,
At
yeah,
that.
please go ahead. Yeah,
So with this slide, are you saying that we are giving the decision to the program to set the rules for us? Because earlier in the traditional programming, we are defining the rules.
yeah, yes. Exactly. This is what we are suggesting, that when you provide the data, when you provide the answers, right? The relationship will be identified by the machine learning algorithms.
No,
Rajesh.
yeah, that's right. Let me elaborate my question further.
Yeah, yeah, sure, please.
So if it is a simple program, we know what is the answer,
Yeah,
right?
yeah,
And we know the answer and we know the data. For example, if you take the previous slide where you have shown the core recognition or people face recognitions, right?
yeah,
Right. So
yeah,
how, where, I don't know the answer, whether it is a car or it is an auto rickshaw or is a bicycle, right?
yeah,
So I
yeah.
don't have the answer for it, all right? I have only the data. That then how the machine learning will, take or, define in a way that, to set the rule for us. I hope you got my
Yeah,
question.
yeah. You have a valid point. And let me pause this question because
No,
I do
no,
not
no
know.
problem. No problem. Yeah, I
But
will take this.
I think your point is pretty valid. It's a good observation, Rajesh. But I really do not know how to. Maybe let's go ahead with the next set of
No
slides.
problem. I mean, I will take
But
this offline as well. Yeah.
oh yes, yes, you can do that, Rajesh.
So,
But at the
so
same
my
time, I
guess
think this will.
is,
Yeah, sure.
I
Please
think
go
my
ahead.
guess is that it might
Yeah,
not have an answer the first time, right? Uh, Maybe first time you give an answer saying the one which has four wheels can either be a car or a bus, right? And then maybe with multiple, you just said, right? I mean, it keeps learning. Uh, it keeps building the methods,
yeah,
right? I think it keeps
yeah,
learning from every time that you keep give an answer. The
yeah,
first time you say that the one which has four wheels are a car, the one which is less than this particular height could be, or more than this particular height could be a bus or van, right? I mean, you keep giving data to the machine and it keeps learning. And over a period of time, imagine volume of data that you're giving it. It keeps learning, and I think at some point it will start.
Yeah. Yeah.
That's just my guess. I do
Here,
not know. I may be
yeah,
wrong also.
Yeah.
you're
Yeah.
right, Kamlesh.
Yeah.
Here also you know the answer because you already know that four wheeler is a vehicle.
Yeah.
So
Yeah.
my
Yeah.
question is broader, where when I don't know the answer.
Yeah. 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 But Kamlesh, thank you so much. You have given
That's
some
right.
direction to me. So Rajesh,
Right. Yeah.
consider, and again, I think we can debate and deliberate further on this.
No, we will take this
Consider,
offline. If needed, I don't want to hijack the training.
uh,
Time.
uh, okay, but just a quick one. I mean, I'm not sure whether maybe the others are probably also interested to knowing this particular offline conversation, Rajesh. I'll take a quick minute, right, and then we'll move on, and maybe a better response I will be able to develop and come back. But imagine that you have a data which uh, has a detail of consumers buying probably iPhone, right? Unstructured, and we are jumping the gun. In unstructured methods, right? Sorry, not unstructured, unsupervised machine learning. Clustering is one of the method, right? And when we do clustering, what essentially the machine learning algorithm will identify that what is the proximity between the two different data points, right? Now, once you have identified the proximity, you know that exactly what you are going to respond to. What is the problem that you are actually trying to respond, right? It is what you are trying to do is to identify where the cluster is actually residing in a way, right? So maybe over a period of time, Rajesh, you know that, okay, what exactly a problem that you are supposed to solve. You still do not have data points, I mean, the labels, but you still know that, okay, maybe this is the problem that you're supposed to solve, right? And over a period of time, the machine learning algorithms will learn, right? And it will identify, okay, what is the distance that we are calculating, whether it is in centimeters, inches, and so on. And there are specific distance identification algorithms which exist in unsupervised machine learning, Rajesh. Maybe this can be a possible response to your question, Rajesh.
Can I add on to something to this? Like, I feel like, and Dave.
Yeah, yeah, sure. Dave, please go
Yeah.
ahead.
So, like as Rajesh said, when we don't have answer, how will we identify? So here the answer is labeled or unlabeled. And when we have the answer, it is the labeled data we have. When we don't have the answer, it's the unlabeled one. So that's the identifying point where we
Yeah,
apply supervised learning and where we apply unsupervised learning. If we have the answer, we train the model over that answer. But if we don't have the answer, then we let the model decide, let the model cluster it based on the
yeah,
similarities. That is the whole concept of supervised and unsupervised.
yeah, yeah,
That makes sense. Yeah, okay. Thank you.
yeah. Yeah, thank you so much, Dave. I think this is a better way to put up the response. Rightly called out. Yeah. Okay, shall we move on? Okay. All right. So if you look at this particular data set that we have, it's a very basic one, right? We have got different columns, say, and we are predicting the final exam score of a student. So we have got number of hours a particular student is spending, attendance in the school, right, and the past grades, right, and this is the final exam score, right? So here, if you look at it, uh, all these columns, study hours, attendance, past grades, right? These are features, right? And feature engineering is an important concept in itself. Studying these features, how they are related to the final output. That's the purpose of feature engineering. So we have got a label here. This is the output, and we have got data. So if you use this data to predict the final exam score, this is what is supervised learning. I mean, this is an example of that. Right? Let's pick up a more difficult example, right? Here we are predicting insurance charges for individuals. This is the data for each patient, the age, then gender, BMI, if they have children, right? In case, whether smokers, and from which region they are coming from. And then there are charges. So if you, in a way, we will try, I mean, this kind of problem is given to the data scientists. They will try to understand what kind of relationship these columns and the charges, uh, or what kind of relationship exists between them. Right? So typically here again, features are age, gender, and so on, and the label, which is the output, is policy charges. Right. So this is again a supervised learning example because we have got a label that we are going to predict. Let's look at the other example. Right here, uh, uh, we we are measuring, I mean, we are actually kind of picking up certain elements from the emails which are coming in your system. And it's a spam email detection data that we are trying to generate. Right? So here, in case if a email contains free word, right? So this column actually is representing it. If the domain name, the sender domain name is known, right? It is again qualified as 0 and 1. If And then we are also adding how many links are provided in that particular email. And this is the data, which is the real one, where we know that, okay, this particular email is spam. 1 is representing yes, 0 is representing no, right? So if you give this data and you ask your algorithm to identify whether this is email is spam or non-spam, it will do that. But this is a classification one where we are defining there are two different classes, yes and no. Correct? Are we good with this? Okay. Now, the supervised machine learning, it has got two different flavors. One is regression. Regression is where you predict the continuous numerical values. Say, for example, you write a program that can help you predict the revenue of an organization, right? Marks of a student, right? The moment you say that, okay, whether it is pass or fail, it is no more regression. Uh, Again, we have given some example predicting house prices. This is typically this particular problem is available on Kaggle, and that's why I always pick up this example so that you can go ahead and download that data. It's US house prices. You can download it and play around, right? You can build models around it. Then exam scores, we already spoke about. Temperature, maybe in a particular city in a particular duration of time in the calendar, right? The key point here is the output it can have different range of values. It's not fixed. It's so you cannot contain it. Then comes classification. When you are supposed to predict a particular class, this is where the classification comes into the picture. Say, for example, disease, positive, negative, right? Image recognition, cat, dog, bird. It's a classification problem, right? The output is very discrete, so it's very limited one. And that's why it is not continuous. I mean, if you go back and in your school days, we had studied about continuous and discrete. Continuous, I mean, it's flowing, and discrete has got specific values in it. So this is classification. If I do a pictorial representation of this is classification, where in a way your program is, or maybe your own intelligence is helping you to identify there are two different classes and there is a separation that you're doing. Maybe just take it to the next level where you are identifying, doing a difference between cats and dogs. Right? So you are separating them. Right? Whereas when it comes to continuous data points, this is the representation. And this is again, you would have studied in linear equations. Right? Example here is if it is a bot or not. And lot many, I mean, almost every web page that we develop these days, make sure that we are able to identify the user who is coming onto the system, whether it's a bot or it's a non-bot. Right? It's an example of classification. And in case if we are predicting some numbers, house sale price, it's a regression one. Okay, so let's predict. Is it regression or classification? Anyone?
Regression.
Regression, Akshay. All right. Okay. Who else would like to respond to that? So what we are doing here, we are actually predicting the final exam score, right? It is a continuous one. So Akshay is right when he says that it's a regression one. So it's a regression one, and features we have got study hours and all, right? We have got label as final exam score, and algorithms that you can apply, linear regression and decision tree. Is this classification or a regression?
Classification.
Classification.
All right. Okay. Let's move on. All right. So this is, let's talk about this, right? We have put up multiple problem statements. So here in the first problem statement, we are predicting the price of a house. We already have discussed. So what kind of problem statement is this?
Like in classification and regression.
Yeah. You have to
Uh,
specify whether it is
Regression.
classified regression. Okay.
Yeah.
Age, income, and debt ratio. Loan approved, yes and no.
Classification.
Age, annual mileage, brand score, resale price.
Regression.
All right. Study hours, attendance, pass grades, final exam score. We already did that.
Regression. Yes.
Email, already we did that. And then we have got petal length, petal width, and sepal length, flower species.
Classification. Classification.
No, regression maybe because there can be multiple flower species. No.
It is not a continuous number, Mayank,
But
right?
we are
Even
classifying it into different type of the length of the and width of the petal length.
correct,
So it's
correct.
regression. Yes.
It's classification, not regression. We are not dealing with numbers here.
Okay.
So maybe
Okay.
flower species. Um,
But
it can
classic.
be rose,
No.
marigold, and so on.
Okay. So there can be multiple classification types, like more than
Yeah,
two.
yeah, yeah.
Okay.
So the meaning of discrete is that you have limited options.
Okay.
It cannot go to infinity, right?
Yeah. Okay.
Okay. So this is regression, classification. We have got regression, and I'll let you go through this slide. There are some examples which I'm calling out, the different algorithms which are predominantly used. Please try to pick up, at least get familiar with these algorithms. It will be helpful. Okay, let's move on. Now let's talk about the process cycle. When you are given as a data scientist, when you are given a problem statement, right? How do you go about it? How do you solve this, right? So the first part is where you uh, define the problem statement. You work on the problem statement, right? Say, for example, when we were given the data about a student, what we were supposed to do, we were supposed to identify whether a student will, what kind of scores the student will get, right? So, and you have also accumulated the data, right? And it is important. Why it is important? Maybe it is important for the teachers to know that, okay, what is going to be the pass percentage. If you see how the different school announce their results, they say that, okay, 95% have got passed out in CBSE 12th class and so on, right? So this is important for the teachers, right? But this is the problem definition that has been identified that, okay, maybe they want to improve. The larger problem statement would be a particular school wants to improve their passing scores of the student in board exams, right? So this needs to be very clearly defined. Not many times what happens that, and why it is important for a data scientist is that not many times when you're dealing with the top leadership, uh, not necessarily they will have an explicit problem statement in their thoughts, right? So you have to probe them, maybe interview them, not probe, maybe is a stronger word, but you have to go and check, okay, what is that they are looking forward to. And then maybe you have to identify, okay, this is the problem statement that you can solve, and you take it back to them, and maybe you will get an approval. Right? So you have to spend a lot of time in defining the problem statement. Lot many times, data science programs fail because this particular step is not taken appropriately. Okay, so once we have identified the problem statement, the data needs to be gathered, right? And the kind of modern problems that we are facing, the data gathering becomes very, very important. Not only the internal data that you need to consider, but also you have to support, you have to get the data from third party. Say, maybe if you are predicting the share price of a particular script, right, a particular organization, you have to get a lot of data from third parties. You need to gather data. You need to identify what are the features that are important, and you need to know what are the labels that you are going to predict. This is the step two. Third step. This is very, very important for a data scientist. In case if the problem statement is not well defined, you can go back and say that, okay, this cannot be worked out. If you don't get data, appropriate data, right, you can always go back and say that, okay, this is not good enough. Right. I mean, there is an external dependency on all the first two steps. The third step is completely owned by a data scientist. You have gathered the data, right? And you are supposed to do cleaning and pre-processing. When you do cleaning, you handle the missing values that we also discussed during the Python classes, right? We remove duplicates. It's absolutely non-negotiable. We normalize features. We'll have a separate conversation around it. But imagine, just to give you an understanding, right? A quick one. There are two different columns, maybe age and the salary of an individual, right? Both of them are participating in the algorithm building, right? Age and salary. Now the salary can be in lakhs, correct? Age will be two-digit number most of the times, right? Now when you do this comparison between them, age and salary, they may have the similar kind of impact on the output. However, because the salary numbers are substantial, salary will have much more impact on the output as compared to age. And we do not want this. So what we do, we bring them down to a level where they actually can be compared to each other. And how do we do it? We'll talk about in the subsequent conversations, right? So the normalization is completely owned by the data scientists. If they miss it, the accuracy will take it all. And then we encode categorical data if needed. So most of these algorithms, okay, let me step back. Uh, Most likely, we are not going to write algorithms. We are going to implement the algorithms which are already defined. I hope we are clear on this. Most likely, when you write a particular algorithm, this is where mathematics and other models comes into the picture. Right? And these are mathematicians' job, not really done by the data scientist. So the data scientist should be given the data, should be given the problem statement, and then what is the output, and they will bring all these algorithms which they know based on their experience that this particular algorithm will give the better results. And they do a lot of experiments. They apply multiple algorithms and then see, okay, which one is actually giving the better results. So they do all such kind of things. but they do not write the algorithms by themselves. It's so when we are talking about categorical data. Sorry, I got deviated a bit. But encoding a categorical data is where say cat, dog, and say some other animal as well, maybe lion, right? If you pass these details to these algorithms, they don't respond well to the structure to the textual data. They respond well to the numbers. So what we do generally, we take up the data, almost everything we convert into numbers using normalization, using encoding. We'll talk about it how we will do it. But imagine that if we have got three different categories or classifications that we have, say cat represents one, two represents dog, three represents maybe lion, and so on. This is typically how we do encoding, and there are various methods how you do encoding. So we'll talk about that. But data cleaning and pre-processing is completely owned by data scientists. So we cannot miss out on that. Once this is done, the pre-processing is done. Now what do? You divide your data into two different packets. So as a data scientist, this is the data that you have is the only asset for you to do some predictions. So what do? You divide this into two parts. One, wherein you will take it and push it to the machine learning algorithm and will train. Say you have got 100 rows, 80 rows, assuming you are doing 80 to 20 split. 80 rows, you will pass it to your algorithm. It will try to understand the relationship that exists between the output label and the other columns, right? It will create some kind of equation between them. This is how it works, right? And then once the model is created, that the remaining data, which is actually the test data, you will pass this data to check whether this algorithm and the equation is responding appropriately or not. So say for example, 3 plus 4, if you can recall, right? 3, 4, not 3 comma 4 and output 7, right? So the output is machine learning will predict that there is an addition that is taking place. But you have some more data elements, maybe 5 and 6, right? So in case 5 and 6 also is leading to 11, that means probably your algorithm is responding appropriately. And that's how we measure the accuracy, right? So we divide the data into two parts, training set and test set. Training through which you train the model, test through which you test the model. Are we okay with this? Doubt? Questions? Okay.
Quick question.
Yeah, you
Yeah,
can go.
Rajesh.
I'll take it up after.
No, anyone of you can go ahead.
Okay. So I mean, how are we defining that training set should be 80% and testing set should be only 20%?
Yeah. So, Rajesh, again, there is an experiment that needs to be done on that. There is no clear recommendation. In the industry, there are two different split that we do generally. It is 70-30 and 80-20. I when I build models, I generally prefer 80-20 split, and that's why I have quoted it here. But when I see some low code, no code tools, I see that there is always a separation of, I mean, split of 70-30, not 80-20. So there is no clear cut direction given on that. As a data scientist, you have to gauge, okay, how much data that you need to effectively train the model and how much data that you need to test it out. I would not recommend going beyond 70-30. So it should not be 60-40. Otherwise, the training will be on the weaker side. 30% data is sufficient for you to train, to test. Sorry.
Yeah. So so just to add on to it, Tarun, like when I did the similar use case for MSc data, so I
Uh-huh.
pulled, I extracted the daily volumes of data on NSC site. I trained the data, and when I tested it with the 20% of it, basically what I mean to say here is it's basically there are different parameters where that would define the training set percentage as well as the test set percentage. So over a period of time, you will see whether your model is trained well
Yeah,
to at least give you the predictions percentage to an acceptable parameter.
correct, correct. You're
So
absolutely spot on.
it's on different use cases, the parameters would change accordingly. Yeah, as you rightly pointed out, the 60/40 model is completely avoidable.
Yeah, 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 yeah. Uh, Not many, but there are certain algorithms which also help you to. They also give you some directions that probably what can be the split. Yeah, yeah. Kamlesh, you have a question?
Yeah, so I'm just trying to think in a practical way. Now, supervised learning, is it used for data modeling? Say for example, I have to model a data based on some X number of tables that I have, right? I mean, all those tables are of different types. I mean, holds multiple different data. Now, how do I give the training set and how do I give the test set then?
Uh, okay.
I'm
So,
talking about, say, let's say relation RDBMS.
yeah, yeah. So, when you're talking about relational data, Kamlesh, since there is already a relationship that exists, what you need to do, advised is that you bring the relational data into a single tabular format, right, where you create joins, right? You have a single set where you have gathered the data from table A, table B, and table C. Say, for example, customer master detail, customer transactions, and maybe some grievances, right? You have to bring all these together, right? And maybe customer churn is something that you are predicting. So when you are dealing with multiple data points, you have to bring them together and qualify it for a particular customer. If you are if your problem statement is to predict whether customer churn will happen or not. Kamlesh. You're not comfortable with this
No, I'll
response,
probably
right?
come with a better example. I was trying to correlate with something that we're doing at work, but I'll try to come up with the right
Yeah,
example. Maybe.
yeah, yeah, yeah. Okay, we can actually have a conversation, follow-up conversation on that as well.
Or maybe can I
Maybe
post that question in the WhatsApp?
absolutely. Please go ahead and do that. Yeah. Okay, quick one. So let's move on. Then uh, you once you have done the splitting of data, you need to identify which algorithm you are going to do. You're going to use. Now this is very typical. I mean, the more experience you gain, the more nuances you see in the data, your hand will become better on this. Right? Over a period of time, while we talk about many algorithms out here, I have seen two different algorithms, um, XGBoost and Random Forest, giving the best possible responses. These are the favorite algorithms which are used by the data scientist. Random forest is very resource intensive, so it may take a huge number of hours. Just in case if you are training the model on a larger data set, so it becomes a challenge. XGBoost is much more optimized. But again, depending on the kind of problem that you are solving, and we'll talk about maybe we'll try to give you a direction how based on the use case that you're solving, which algorithm can actually give you better results. But in this particular step, step number 5, you identify which algorithm you are going to pick up. Once you are done, the data that you are feeding into this algorithm will train the model, right? And the model will learn from the patterns and the relationships that exist in the data. Right? And once the training is done, you pass the data to this learned algorithm, the test set, and it will help you identify what is the accuracy, whether it is 80% accurate, 70%, 90%, right? Then, as a data scientist, again, you may be given with some kind of benchmarks that what should be the accuracy level. And it also depends on the kind of use case that you are supposed to solve. So in one of the cases, I generally share this example that we were called by hospital, and they wanted it was a US based hospital, and they wanted to do a prediction on whether a particular patient will commit suicide. They were dealing with the patients who were undergoing a lot of mental health challenges, right? Now imagine, and I was sitting in that conversation, I was thinking that okay, this is a very difficult one to solve. 1% accuracy challenge here and there, and it's a matter of life, right? So and in case if we build up a model which is helping you to identify the revenue of your organization, maybe 10% here and there is okay, right? So depending on the use case that you're solving, and it will go back and stitch to the first problem. What is the business statement that you have? So based on that, you will give a go ahead whether the model is good enough or not. Uh, we also do another one more round of, once you have identified that okay, the model is okay, you put it into production. Right? And now there are two things that can happen, and one of these things will happen prior to putting into the production, which is underfitting. So underfitting is an example where the model is not scoring well, right? Whereas overfitting is on the sits on the other side, right? So overfitting is when your model is able to process the data appropriately. It maybe it is giving you a high accuracy, 90%, something of that sort. However, the moment it reaches into the production, it fails. The accuracy drops, right? So overfitting, and why it happens, we have a separate conversation around it. But largely because the machine learning model, maybe it got biased towards the test data or towards the learning data, right? And test data also was not able to attack it, all those biases which were incorrectly assessed in the model. So overfitting and underfitting is something that you need to take care of, right, as a data scientist. And once you put the data or the model into a production uh, cycle, it will be used by different stakeholders, and you will be getting more data packets, right? So maybe you have to go back at certain point in time, retrain your model. This is exactly typically which is happening with LLMs, right? They are retraining their model after every month, and so they are helping us. I mean, they're publishing as well that on how many parameters these LLM models now exist on, right? And they are also calling out what was the cutoff date, right? So the retraining and model improvement, that's also comes under the tag of ML operations, ML ops, right? That itself is a job category. Just like DevOps, now we have got ML ops. Okay. So this is a pictorial representation of the process that we have done. We go through that data collection, then we do data cleaning. We split into train and test, 70, 30, 80, 20, whatever you want to choose. Then you choose the algorithm, you train the model, you evaluate the model using the test data. You verify whether it is overfitting, underfitting, but underfitting you can verify, overfitting will happen in the production only. Then over a period of time, you retrain and improve your model. Okay. So this is what I wanted to cover. I'll stop here, but I can take up questions.
Arun, just a suggestion. I think, is it possible to have a recap or redo the session? I think all these concepts are a little deep, at least for me.
Okay. Yeah.
I mean,
Sure.
maybe with
We
some sufficient examples with all these concepts. I'm okay. I'm not sure if others are okay. Can we do a session tomorrow at the same time? Maybe
Um,
additional fun.
I am up for like examples. I agree. Actually, I also wanted to say that, but tomorrow won't be possible. Maybe we can do it in the upcoming session.
Okay. We can figure this out. But what is your explicit ask, Kamlesh? You want more examples to be
More
discussed?
practical examples, yes, yeah. I mean, 1 hour with so many concepts. I mean, I at least understood at the surface level.
Yeah. Yeah.
Yeah,
Yeah.
let's sync and then.
Because yeah, what I matlab, understood by supervised learning is that we are just um, you know telling the computer, like giving a lot of data for it to understand and learn and not to fault when it has to actually evaluate something, is what I have understood. But I would like to understand in a much more nuanced way how it would be used in today's time, like for
Or
Yeah.
in other
what.
words,
Yeah.
I mean, how do we see this practically?
So see, okay, I think maybe the way we generally organize these sessions, right? Uh, we have given an exposure on how this overall system works, right? Then we bring difficult examples. So we raise the bar, right? So there are some practical examples that we have, the data that we have gathered, right? We'll expose the data to you. You will also be building those models. We will be also building those models, right? And this way you actually will have a better path. So it is not that the journey on supervised learning is ending here, right? We are going to make it much more complicated. But uh, this was the simplest way to introduce the concept, Kamlesh, Shivani. Right?
Just to add on to it,
Yeah.
the best approach is, whatever the theoretical knowledge we gathered now should be mapped to the practical examples.
Yeah.
Uh, uh, Kamlesh, whenever whatever the use case you want to bring in, just feed those use case or data what you have into these categories. Whether you already have the data collection, whether or what type of data cleansing or pre-processing you wanted to make for the data, or something like that. So that wherever you start, you will get raise or raise questions to understand it better. Because that would give you what kind of algorithm you need to use for that particular data. Because
Yeah.
the same algorithm won't fit for all.
Yeah. So I think that's a good idea, Rajesh. Thank you so much for pointing that out. Just in case, Kamlesh, you have some data which you can where you can take off the PI and confidentiality part, right? Will be we'll figure out how that can be solved. If you have a problem statement in your thoughts, we can make the next session very focused on the problem statement that you are going to bring in. Will that be helpful?
I'll try to get some data.
I
Yes.
have an idea about the problem statement.
Okay,
So
yeah, Shivani, go ahead.
yeah, product behavior can be supervised as well. But it doesn't have to be. But I think a lot of e-commerce are using supervised machine learning methods. So I was thinking maybe purchase behavior or consumer behavior could be studied. What kind, and for a particular store, how are they buying, why are they buying, what kind are they buying, for how much are they buying, and stuff like that.
Okay. 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 Sure. Uh, we'll try to figure this out. In case if you can figure out the data set at your end, you may bring in. Uh, I have an example where um, uh, we talk about the flight predictions. It's a very interesting data set that we have. Right. Uh, Generally cover that in the third session in machine learning, but I can actually prepone it. I can break it in the next
Let's
conversation.
my suggestion would be let's take the real-time example which Shivani also mentioned. So let's create from scratch, like the behavioral data. Let's collect the data on different aspects, like on the behavioral patterns of the consumers or end user
Okay.
with some mock data, because nowadays
Yeah.
we can very well generate the data as well. Right?
Okay. Sure. Point taken.
Yeah,
We'll
so,
we'll
so
we'll
that
go
it
ahead.
will be easy. yeah, it will be easy for correlate how to view the data and how to make that data cleansing all each step by step.
Yeah, yeah, sure, we can do that. The one of the challenges that we will be facing, while since you spoke about data cleansing, we have not yet covered some of the theoretical concepts. So we'll see that, okay, how that can be covered along with the example, right? Right. Okay. Let's see if we can figure out this data set.
Sure.
Okay. So I'm pretty much done. You have any other question apart from this? Okay. Okay. So I will stop here, right? And I'll try to release this recording as soon as possible, so that at least this will definitely require a recap at your end. And I'll also share you the PDF of the presentation that I have shared.
Yeah.
All right. Okay. If
Thanks.
that's the case, then let's stop here and we'll meet on Wednesday. We are not meeting tomorrow. We are meeting on Wednesday, right? At the same time. All right. Thank you so
Thank you.
much. Thanks, everyone.
Thank you. Thank you
Thank
so
you. Thanks. Bye.
Okay, thank you everyone. Bye.
Yeah. Thanks, Akshay. Thanks. Thanks.
Maybe it will
Arun.